150 CE1. Series. Instruction Manual. Synchromotion. Simultaneous control. Read and follow these instructions and all safety blocks carefully. Have only trained and qualified persons install, operate, or service this unit. Give this manual to the operator. For help, call your distributor. -1-. Thank you for selecting Den Arc Welding Robot All Mega Series. All Mega Series are the robots with high performance and various functions developed by making full use of the latest technology. Since the knowledge of welding peculiar to a welding machine maker is applied to both hardware and software, we are sure that each user can be fully satisfied in order to use the superior performance and the abundant functions safely and fully. Be sure to read the following instruction manuals including this manual and other attached documents, and understand the knowledge of the machines, safety information, and notes thoroughly. Instruction manuals related to the manipulator/per hour series, and the robot control unit FD11 are as follows. Standard manuals. Instruction manual type instruction. Manual no. Main contents. Quick start 1L21700 A point on safety, transportation and installation, turning the power on/off and manual operation, etc. Setup. 1L21700B. Safety precautions. Installing and connecting method. Starting up. Periodical inspection. Solution at the time of failure. Controller maintenance 1L21700K specifications of controller, explanation of each parts, and maintenance, parts list, etc. Manipulator NB4/NB4L/NV6/NV20/NH51L11130. A specifications or maintenance of manipulator, parts, list, etc. Basic operations. 1L21700C. Explanation of manual operation, teaching, automatic operation, file utilities, backing up data, basic operations of arc/spot welding application, etc. External input/output 1L21700H interfacing method with external control device, list of I/O signals and start/halt the automatic operation, etc. Software PLC 1L21700J create program, input/output relay lists, list of command words, etc. Control and maintenance function 1L21700L edit logging, user check, troubleshooting, etc. Application manuals. Instruction manual type instruction. Manual no. Main contents. Application manual arc welding 1L21700F basic settings. Functions for arc welding, teaching, technique, etc. Application manual spot welding 1L21700E basic settings. Functions for arc welding, teaching, technique, etc. Instruction manuals are available other than the above for each optional function that you have purchased. Notes 1. Specifications and information contained in these manuals are subject to change at any time without notice. 2. The screen display of a teach pendant shown in the manual are described as examples, which may be different from the actual ones. 3. Although we cautiously compiled this standard specifications to eliminate as much error as possible, we do not take any responsibility for damages resulting from neither direct nor indirect errors. 4. The manual is a part of robot products. When transferring or selling off a robot, be sure to append the manual. 5. No part of this manual may be reproduced without permission. 6. Prohibited altering or remodeling. Do not alter or remodel our products. You may get injured or have your equipment damaged because of fire, failure or malfunction caused by altering or remodeling the product. The warranty does not cover any altered or remodeled products. Be sure to read instruction manuals before use notice. Notes on safety, before installation, operation. Be sure to read Chapter 1 Points on Safety in Setup Manual and other attached documents thoroughly and acquire all the knowledge of machines, safety information, and precautions. Furthermore, before maintenance, inspection, and trouble scene, be sure to read Controller Maintenance Manual and Manipulator Manual and other attached documents thoroughly and acquire all the knowledge of machines, safety information, and precautions. If operating machines in a wrong way, the accident resulting in various ranks of injury or death, or damage may occur. In order to call attention to wrong handling, the following 4 ranks of safety notes: danger, warning, caution, and important, are provided. Danger. Cases where a mistake made in handling is likely to cause the user to be exposed to the danger of death or serious injury and where the degree of the urgency imminence of the warning given for the danger to occur is at the high end of the scale including high-level danger, -2-. Warning. Cases where a mistake made in handling is likely to cause the user to be exposed to the danger of death or serious injury. Caution. Cases where a mistake made in handling is likely to cause the user to be exposed to the danger of minor injuries or of property damage only. The following symbol is also used for particularly important checkpoints. Important. This is a particularly important checkpoint. Note that even the matters which are described as caution can result in serious accident depending on the conditions. Be sure to keep the safety notes since they describe very important matters. The meanings of serious injury, minor injury, and damage described above are as follows. Serious injury, injury which has the after effect by loss of eyesight, and injury, the burn high/low, temperature, and electric shock, fracture, poisoning, etc., and that which requires hospitalization and long-term treatment as an outpatient. Minor injury, injury which does not require either hospitalization or long-term treatment as an outpatient. A burn high temperature, low temperature, and an electric shock. Damage, direct and indirect damage in connection with damage of property and equipment. Chapter 1 Introduction. This chapter describes definitions of terms used throughout this manual. A simple outline of control processes: synchromotion control, simultaneous control, and multi-unit control, and an explanation of how to use this manual. 1.1 Terms commonly used in this manual. 1-1 1.2 How to read this manual. 1-2 1.3 Control processes. 1-3 1.3.1 Synchromotion control. 1-4 1.3.2 Simultaneous control. 1-4 1.3.3 Multi-unit control. 1-5 This is dummy page. Do not erase. 1.1 Terms commonly used in this manual. 1-1 1.1 Terms commonly used in this manual. This table contains explanations of terms used in this manual. Table 1.1.1 Frequently used terms. Terms explanation. Mechanism. This term is used to refer to a unit, such as a manipulator, positioner, slider, servo, gun, or servo drive, that cannot be subdivided further as a control group. Multi-mechanism. A configuration, such as a manipulator equipped with a positioner, slider, and servo gun is referred to as a multi-mechanism. If a multi-mechanism is to be used with manual operation, it is first necessary to declare which mechanism is to be operated. Unit. This refers to the increments in which a program is created. On some occasions, only one mechanism configures the unit. On other occasions, multiple mechanisms, multi-mechanism, are involved. Multi-unit. Normally the entire system incorporates a single unit, but it is possible for a system to have multiple units in order to provide more efficient operation for the system overall. When multiple mechanisms are connected, the term multi-unit is used to describe this type of configuration. In a multi-unit setup, all of the mechanisms connected to a single controller are distributed among several units. Operation programs created using those units can be run simultaneously. In other words, the individual units can operate in parallel, thereby substantially increasing the work efficiency of the system as a whole. Normally, unit settings are performed in accordance with the customer's instructions by our service personnel when equipment is shipped from the factory or upon delivery. Synchromotion cooperative control. This is a method of controlling the tool position, posture, and speed relative to work located on auxiliary axes, such as positioners. It is also called cooperative control. Multi-synchromotion, multi-cooperation. This term refers to a function for switching dynamically between auxiliary axes under cooperative control. Specifically, if there are multiple positioners located around a single manipulator, it allows operation to proceed continuously while switching among the positioners under cooperative control, using the multi-unit function. Cooperative control operation programs created using individual units can be called one after another from a parent operation program. Simultaneous control. This method allows multiple mechanisms to be controlled at once. Cooperative control allows control over position, posture, and speed relative to the work. Simultaneous control permits control the position, posture, and speed of tools relative to the ground. Collaboration. This function is not supported at the present time. This term refers to a function that supports the use of multiple handling manipulators to transport a single piece of work. Twin synchromotion, twin cooperation. This function permits two manipulators to perform cooperative control on a single piece of work. Specifically, this function could be employed to have two manipulators perform arc welding on both ends of a long piece of work held by a double support positioner at the same time. Multitask. The function that allows multiple operation programs to run independently and in parallel is sometimes referred to as multitask. 1.2 How to read this manual. 1-2 1.2 How to read this manual. This manual describes operations and functions that are different to those of the manipulator as an independent system. It is intended for persons who use a multi-mechanism system, a method whereby multiple mechanisms are controlled by a single control unit. You can readily learn how to operate the manipulator system by using this manual as follows. 1. Look at 1.3 control processes on page 1-3, and check the robot control process and the method of use. 2. Next, follow the instructions in the table below. You can see how to read this manual. For a description of multi-cooperation and multitask based on the multi-unit specifications, see the instruction manual multi-unit. Table 1.2.1 How to read this manual. Number of units control process / method of use Chapter 1 Chapter 2 Chapter 3 Simultaneous control cooperative control -1 single unit twin cooperation. Please read. There is no need to read. The contents of each chapter are as follows. Chapter 1 Introduction. This is the chapter that you are now reading. It gives a brief outline of frequently used terms and control process synchromotion control, simultaneous control and multi-unit control. Chapter 2 Teaching with cooperative control and simultaneous control. Be sure to read this chapter regardless of the control process used and the method of use. It describes the method of switching over the unit and the mechanism. Also the method of cooperative manual operation and the method of teaching movement commands. Chapter 3 for operators using the twin cooperation. This chapter describes manual operation and also functions, such as teaching support functions, which are unique to a twin cooperative system. It is intended to be read by workers who use twin cooperation for performing arc welding using two manipulators simultaneously. 1.3 Control processes. 1 to 3. 1.3 Control processes. This controller is equipped with the functions outlined below. They allow the controller to control multiple mechanisms connected with it simultaneously, thereby permitting the robot system to operate more efficiently overall and producing high-quality welding results. Each of your robots is configured for one of the following control processes. They are also optimally configured and fine-tuned for their specific applications and modes of use. Simultaneous control synchromotion control, cooperative control multi-unit control, multi-mechanism. Simultaneous control cooperative control. Multiple mechanisms start out simultaneously toward their target step and reach it simultaneously. Control of the position, posture, and speed of tools relative to the work. Single unit. Control of the position, posture, and speed of tools relative to the ground. Cooperative control and simultaneous control setup example. Multi-unit. Cooperative control. Simultaneous control, or single mechanism control for individual units. Cooperative operation at some times. Dynamic switching of targets of cooperative control, multi-cooperation. Manipulator grips work jig, less cooperation. Two manipulators weld simultaneously twin cooperation. Multiple manipulators work in cooperation collaboration. At some times, multiple units start operating in parallel and each works independently multitask. Example of switching between independent, parallel operation and cooperative operation. Cooperative control of positioners. Simultaneous control of positioners. Simultaneous control of sliders. Cooperative control of positioners and sliders. Twin cooperation. Jigless cooperation collaboration. Multi-cooperation. Examples of the application of cooperative control. 1.3 Control processes. 1 to 4. 1.3.1 Synchromotion control. Synchromotion control is a control process in which multiple mechanisms, manipulators, auxiliary axes, etc., operate simultaneously and the position, posture, and speed of the tools is controlled relative to the work. It is also sometimes referred to as cooperative control. For example, in an arc welding system configured as shown below, the manipulator could maintain at all times the optimal torch posture and speed relative to the work mounted on the positioner. Fig. 1.3.1 Arc welding using synchromotion control. 1.3.2 Simultaneous control. Simultaneous control is a control process in which multiple mechanisms, manipulators, auxiliary axes, etc., operate simultaneously. Multiple mechanisms begin to move toward their target step at the same time, and they stop moving at the same time. Cooperative control allows control over position, posture, and speed relative to the work. Simultaneous control permits control the position, posture, and speed of tools relative to the ground. Simultaneous control is sufficient for applications such as the following. Cases where it is possible for the manipulators to maintain an optimal posture at all times relative to the work mounted on the positioner controlling sliders on which manipulators are conveyed. 1.3 Control processes. 1 to 5. 1.3.3 Multi-unit control. The multi-unit control divides up all the mechanisms connected to a control unit into a number of groups called units and controls the robot on a unit-by-unit basis. The units are preset prior to shipment from the factory or prior to delivery in accordance with what the user has specified. Manipulator. Positioner A. Positioner B. Unit 1. In this group, the manipulator exercises synchromotion control for positioner A, with the multi-unit function. All the mechanisms connected are divided up into a number of groups called units. Normally, the initial settings for the units are performed prior to shipment from the factory or prior to delivery in accordance with the user's specifications. 2 units are defined in this example, but other units can also be divided up into other groups. It is also possible to divide up the units into an only manipulators or only positioners group. The task program is created by each of the units. Unit 2. In this group, the manipulator exercises synchromotion control for positioner B. Unit 1. What is a unit? Unit 2. Program in which the manipulator exercises synchromotion control for positioner A. Unit 1. It is possible not only for the program's units to be started up individually but also to provide a main program and then switch between the units while operation is in progress by calling a program of each unit from the main program. Program in which the manipulator exercises synchromotion control for positioner B. Unit 2. Fig. 1.3.2 Thinking behind the multi-unit with multi-cooperation robots. This figure shows a simple outline the concept of the multi-unit. Note that it is only one example. By using a multi-unit, you can operate the robots more flexibly and efficiently. For details, see the instruction manual multi-unit. 1.3 Control processes. 1 to 6. Note Chapter 2 Teaching with cooperative control and simultaneous control. This chapter describes definitions of manual operations switching among units and mechanisms and work coordinates on multi-mechanism systems. It also describes the teaching methods used with cooperative control and simultaneous control. 2.1 Before performing teaching or manual operation. 2 to 1 2.1.1 Switching between units. 2 to 1 2.1.2 Switching between mechanisms. 2 to 2 2.2 Coordinates. 2 to 3 2.2.1 Work coordinates. 2 to 3 2.2.2 World coordinates Absolute coordinates. 2 to 4 2.2.3 Registering coordinates. 2 to 5 2.3 Cooperative manual operation. 2 to 6 2.4 Teaching with cooperative control and simultaneous control. 2 to 9 This is dummy page. Do not erase. 2.1 Before performing teaching or manual operation. 2 to 1. 2.1 Before performing teaching or manual operation. If multiple mechanisms are connected to the system, it is necessary to switch among units or mechanisms when performing teaching or manual operation. 2.1.1 Switching between units. If the system has multiple units defined multi-unit specification, it is necessary to first select the unit to be the target for teaching or manual operation. Motor power may be either on or off. This operation is unnecessary if multiple units are not defined. No switching takes place even if the unit switching operation is performed. Switching between units. 1. The currently selected unit and the mechanism defined for it are displayed on the Teach pendant. Confirm the current unit selection by checking the display of the Teach pendant. Mechanisms included in the currently selected unit. Number of unit being selected. Number and name of mechanism being selected. Enable plus unit. Mechanism. 2. While holding down Enable, press unit/mechanism. The unit selection screen is displayed while Enable is held down. 3. The units are switched in sequence by pressing unit/mechanism while Enable is held down, so switch to the desired unit. 2.1 Before performing teaching or manual operation. 2 to 2. 2.1.2 Switching between mechanisms. After switching the unit, select the mechanism to be used for manual operation. Motor power may be either on or off. Point when selecting the mechanism to be manually operated. Be absolutely sure to switch to the unit to which the mechanism in question belongs. Mechanisms which are not defined for the units cannot be operated manually. For instance, it is assumed that the current unit is Unit 1 and that UNV6 is the only mechanism defined. In this case, mechanisms other than UNV6 cannot be operated manually while Unit 1 is selected. In addition, when the managing unit has been defined, any mechanism cannot be operated manually since the managing unit does not have mechanisms. Switching between mechanisms. 1. The mechanism selected for manual operation is displayed on the Teach pendant. The currently selected mechanism is displayed in color. Unit mechanism. 2. To switch the selected mechanism, press unit/mechanism. The selected mechanism changes and the display of the Teach pendant changes. An example of switching in a unit comprising a manipulator and a positioner is shown below. Mechanism number, manipulator name, mechanism number, positioner name. 3. After switching the mechanism, manual operation using the newly selected mechanism is possible while holding the deadman switches. Press the axis keys to operate the mechanism. 2.2 Coordinates. 2 to 3. 2.2 Coordinates. The coordinates used for manual operation of a manipulator are generally axis coordinates and robot coordinates, machine coordinates. If the unit supports cooperative control, manual operation using work coordinates is also possible. In addition, if multiple mechanisms are connected to the system, world coordinates, absolute coordinates that are unique to the system as a whole may be selected. Axis coordinates. Default coordinates, system robot coordinates, machine coordinates, tool coordinates, work coordinates, world coordinates, absolute coordinates. 2.2.1 Work coordinates. Work coordinates can be selected for units supporting cooperative control. One example would be a case in which cooperative control is used for a manipulator and an auxiliary axis, such as a positioner. Work coordinates cannot be selected for simultaneous control of the manipulator and auxiliary axis, or for the unit with the single manipulator or single auxiliary axis. Work coordinates have a starting point and axis directions fixed at the mechanism on the work side, such as a positioner. If the mechanism on the work side moves, The starting point and axis directions of the work coordinates move with it. X, Z, Y, tool side, work side, Z, X, Y, work side, tool side. Work coordinates for starting point at positioner. Work coordinates after movement of positioner. Fig. 2.2.1 Work coordinates. As shown in the illustration at right above. Moving the mechanism on the work side causes the work coordinates to move to match. When performing manual operation in a case such as this, with work coordinates selected, the manipulator must follow the work coordinates X, Y, and Z directions after they have moved. It is quite useful when performing teaching for cooperative operation. The rotation of the wrist axis performs the same action as the robot coordinates machine coordinates, relative to the work coordinates after they have moved. 2.2 Coordinates. 2 to 4. 2.2.2 World coordinates. Absolute coordinates. World coordinates are fixed at a specified position, unlike tool coordinates or work coordinates. The starting point and axis directions of world coordinates do not change to match the posture of individual mechanisms. If, for example, multiple manipulators are connected, world coordinates can be used for tasks such as having all the manipulators move in the same direction. Z, X, Y, Fig. 2.2.2 World coordinate. In a typical system, the starting point and axis directions of the world coordinates are the same as those of the machine coordinates for the first manipulator. In cases where multiple robots are operating on a production line, the world coordinates can be set to a specified position with absolute coordinates, as per the customer's specifications. 2.2 Coordinates. 2 to 5. 2.2.3 Registering coordinates. Under the default factory settings, each time the interrupt/coord key is pressed, the setting changes in the following sequence: axis coordinates, robot coordinates, tool coordinates. This is the case because, under the factory settings, robot coordinates, machine coordinates, and tool coordinates are registered as rectangular coordinates to be used. Axis coordinates can be selected even if they have not been registered. This controller allows a maximum of 3 sets of rectangular coordinates to be registered. In order to use work coordinates or world coordinates for manual operation, the desired coordinates must first be registered using the following procedure. Note, however, that an operator qualification of expert or above is necessary in order to register coordinates. Registering coordinates. 1. After pressing constant setting, select 5 operation constants. 5 Coordinate registration. The coordinate registration menu is displayed under the default factory settings. Robot coordinates, machine coordinates is set as coordinate set 1 and tool coordinates is set as coordinate set 2. The example below shows the procedure for registering work coordinates as coordinate set 3. Use up or down key to move the cursor to coord 3 plus 3 while holding down enable. Press left or right to select work. 4. Press F12 complete. The new settings are saved to memory and the previous menu is redisplayed. 2.3 Cooperative manual operation. 2 to 6. 2.3 Cooperative manual operation. Cooperative manual operation is a function that causes the additional mechanisms to move to match if one among 2 or more mechanisms that have been defined in the unit as enabled for cooperative control is moved using manual operation. This function is used when teaching movement commands for cooperative operation and when making position or posture corrections. If a manipulator and positioner are under cooperative control, when the positioner is moved, the manipulator moves so as to maintain the same position and posture relative to the work mounted on the positioner. When the manipulator is moved, it operates independently. The positioner does not move. Fig. 2.3.1 Cooperative manual operation. When positioner is moved, if a manipulator and slider are under cooperative control, when the slider is moved, the manipulator moves so as to keep the tip of the tool at the same spot. When the manipulator is moved, it operates independently. The slider does not move. Fig. 2.3.2 Cooperative manual operation. When slider is moved. 2.3 Cooperative manual operation. 2 to 7. If 2 manipulators are under cooperative control, when one of the manipulators is moved, the other manipulator moves to match. For example, moving a manipulator holding the work causes the manipulator holding the tool to move so as to maintain the relative positions and postures of the tool and the work. The same thing happens in the reverse case. Either axis coordinates or rectangular coordinates may be used to perform manual operations. Fig. 2.3.3 Cooperative manual operation by 2 manipulators. 2.3 Cooperative manual operation. 2 to 8. Performing cooperative manual operation. Cooperative manual operation is not possible under all circumstances. In order for it to be possible, the following conditions must all be met. The unit on which cooperative manual operation is to be performed must be selected. The unit's manipulator and auxiliary axis positioner or slider must be enabled for cooperative control, or 2 of the unit's manipulators must be enabled for cooperative control. In the case of a manipulator and auxiliary axis, the auxiliary axis must be the target for manual operation. In the case of 2 manipulators, either may be the target for manual operation. 1. In this example, a manipulator and auxiliary axis are under cooperative control. Confirm that a unit for which cooperative control is enabled has been selected. 2. Press unit/mechanism to select the auxiliary axis as the target for manual operation. When the auxiliary axis is selected, the coordinate set switches automatically to axis coordinates. Press synchronize at the position where you wish to perform cooperative manual operation. The display changes each time synchronize is pressed, as shown below. 3. Cooperative manual operation is possible if POS/pose or POS is displayed. If neither of these is displayed, the system operates in the normal way, each axis operating independently. Point: there are 2 ways to perform cooperative manual operation. Select the one that is most appropriate for the teaching position or the work configuration. Position and posture cooperation: the relative positions and posture of the tool and work are maintained. Position cooperation: only the relative positions of the tool and work are maintained. Manual operation. Position cooperation. Position and posture cooperation. 2.4 Teaching with cooperative control and simultaneous control. 2 to 9. 2.4 Teaching with cooperative control and simultaneous control. Even if the unit has multiple mechanisms defined, the series of operations involved in teaching, moving the mechanism and recording its position is the same as when working with a unit with only a single manipulator. The difference is that recording a movement command causes the position of all of the mechanisms to be recorded at once. It is not possible to record the position of only one particular mechanism. For units with cooperative control enabled, you can specify whether or not to use cooperative control when recording movement commands. If no specification is made, simultaneous control is used automatically. In addition, if multiple mechanisms with different speed standard are defined, you can specify which speed standard will be used. Recording movement commands +1 for a multi-unit specification system. Hold down enable and then press unit/mechanism to select the unit to be the target for teaching. This step is unnecessary if there is only one unit. 2. Hold down enable and then press prog/step to input the number of the program to be created. 3. Using unit/mechanism to switch among the mechanisms as necessary. Use manual operation to move all of the mechanisms to the position to be recorded. +4 to have the mechanisms move from the preceding position to the present position. Under cooperative control, hold down enable and then press synchronize. The indication appears as the recording status. This indication means that the mechanisms will move to that position under cooperative control. Enable synchronize. Use and to toggle between cooperative control, displayed, and simultaneous control, not displayed. If the indication does not appear even when synchronize is pressed while holding down enable, cooperative control is not possible for the current unit. 5. The next step, 6, is where the speed will be set. Before that, however, it is necessary to specify for which mechanism teaching of the speed will be performed. This mechanism is called the speed standard mechanism. Switching among the mechanisms is accomplished using the change speed standard mechanism F key. The number asterisk of the mechanism to be used as the speed standard is displayed here. Depending on the system settings, there may be nothing displayed in some cases. There is no need to make a setting if there is no display. However, in most cases there is no need to be aware of the speed standard mechanism. This step is therefore unnecessary and we can continue with step 6. 2.4 Teaching with cooperative control and simultaneous control. 2 to 10. Hint: what is the speed standard mechanism? The speed standard mechanism is the mechanism that sets the standard for cases where multiple mechanisms move at the same time. During playback, the other mechanisms move at the same speed as the speed standard mechanism. For example, if the unit comprises a manipulator and an auxiliary axis, such as a positioner, and the manipulator is set as the speed standard, the procedure described in step 6 below is used to teach the operating speed of the manipulator. During playback, the positioner moves in synchronization with the movement speed of the manipulator. It also begins and ends movements at the same time as the manipulator. Conversely, if the positioner is the speed standard, the step below will teach the operating speed for the positioner. During playback, the manipulator moves in synchronization with the movement speed of the positioner. It also begins and ends movements at the same time as the positioner. Based on the above, we can see that it is best to be aware of the speed standard mechanism in cases such as the following. When performing linear or circular interpolation, when the manipulator and positioner are under simultaneous control, not displayed, if the position is rotated without moving the manipulator much in order to perform arc welding, or the like. Teaching is easier if one is aware of the speed of the positioner. In a case such as this, the positioner should probably be selected as the speed standard mechanism. When performing straight line or arc interpolation, when 2 or more manipulators are under cooperative control, displayed. If 2 or more manipulators are under cooperative control, it is probably best to select the speed standard mechanism based on which of the manipulators is doing the majority of the movement. 6. Set the necessary parameters, such as interpolation type, speed, and accuracy. 7. Press O, right/rec to record the settings. When step is recorded while the indication is displayed, movement commands corresponding to cooperative control are recorded. Is displayed after the step no. if the indication is not displayed when the settings are recorded. The result is simultaneous control. Operation during playback is as described below, depending on whether or not the indication is displayed and the interpolation type setting. Interpolation type. Indication. Operation during playback. Displayed. All of the mechanisms in the unit move from the preceding recorded position to the present position using joint interpolation. Joint interpolation joint not displayed. Same as when is displayed. In other words, the same movements take place, regardless of whether or not the indication is displayed when joint interpolation is used. Displayed. All of the mechanisms in the unit move from the preceding recorded position to the present position simultaneously. The manipulators move on the work coordinates using linear or circular interpolation, so the position, posture, and speed are maintained relative to the work. Linear interpolation lin or circular interpolation sir not displayed. All of the mechanisms in the unit move from the preceding recorded position to the present position simultaneously. The manipulators move using linear or circular interpolation, but they move independently and without regard to the work coordinates. Position, posture, and speed are not maintained relative to the work. 2.4 Teaching with cooperative control and simultaneous control. 2 to 11 2.4 Teaching with cooperative control and simultaneous control. 2 to 12. Note Chapter 3 for operators using the twin cooperation. This chapter describes the preparations for using twin cooperation, and also the points to note when teaching and also when performing automatic operation. It is intended to be read by operators who use twin cooperation. 3.1 Twin cooperation. 3 to 1 3.2 Preparations for using twin cooperation. 3 to 2 3.2.1 Setup relating to welder. 3 to 2 3.2.2 Setup concerning the input/output signals exclusive to arc welding. 3 to 4 3.2.3 Setup for the screen edit display mode. 3 to 7 3.3 Switching over the welders and mechanisms to be operated. 3 to 9 3.3.1 Switching over the welder to be operated. 3 to 9 3.3.2 Switching over mechanism selected for a weaving on/off operation. 3 to 12 3.4 Teaching of twin cooperation. 3 to 14 3.4.1 Teaching the move command. 3 to 14 3.4.2 Specifying the object welder of a welding command. 3 to 17 3.4.3 Specifying the mechanism that is the object of a weaving start command. 3 to 18 3.4.4 Specifying the mechanism that is the object of a weaving end command. 3 to 19 3.5 Automatic operation of the twin cooperative system. 3 to 23.5.1 Welding start. 3 to 23.5.2 Welding end. 3 to 21 3.5.3 Processing by the welder and robot in the welding section. 3 to 21 3.5.4 Speed of motion in the welding section. 3 to 22 3.5.5 Multi-weaving. 3 to 23 3.5.6 Pause and restart. 3 to 23 3.5.7 Welding on/off during automatic operation. 3 to 24 3.5.8 Weld failure. 3 to 24 This is dummy page. Do not erase. 3.1 Twin cooperation. 3 to 1 3.1 Twin cooperation. This function enables multiple manipulators to perform cooperative control of one work item. Specifically, this function could be employed to have two manipulators perform arc welding on both ends of a long piece of work held by a double support positioner at the same time. This enables two different points to be welded simultaneously, thus enabling the work efficiency to be improved. Fig. 3.1.1 Example of twin cooperation configuration. Important. Multiple manipulators cannot execute search operation commands simultaneously when a touch sensor or laser search is being used during twin cooperation. Each manipulator executes a search operation command, one at a time in the taught sequence. Search operation commands refer to the following: touch sensor, wire length detection SF0, unidirectional search SF1, pattern search SF2, laser search, unidirectional search ZF1, pattern search ZF2. Acquisition of beveling data, ZG1 twin cooperation drift acquisition SF3, can be performed by means of a cooperative operation by multiple manipulators. For the method of teaching using a touch sensor or a laser search, refer to touch sensor or laser search in the instruction manual. An arc sensor or laser sensor cannot be used in twin cooperation. An arc retry function cannot be used on the user settings in twin cooperation. A check welding which is enabled cannot be set simultaneously as multiple welders in twin cooperation. An online change cannot be used simultaneously as multiple welders in twin cooperation. 3.2 Preparations for using twin cooperation. 3 to 2. 3.2 Preparations for using twin cooperation. In order to perform twin cooperation, it is necessary to set up the welder and also set up the input and output signals exclusive to arc welding. 3.2.1 Setup relating to welder. Perform the setup relating to the welder. For this procedure, an operator qualification of expert or above is necessary. when the robot and welder have been purchased at the same time. The setup is normally done prior to shipment, and so it need not be done by the user. The setup must be done if operators aim to do the setup themselves or if the welder is to be changed after the robot was delivered. For further details, refer to the application manual arc welding. Here, a description of the points to note concerning setup for twin cooperation operation is given. Settings relating to how to operate the welder. Set the robot to which the welder is to be connected, and the connection type. When a robot system with the multi-unit specifications is to be used, these settings must be performed for each unit. Point multiple welders connected to the unit are used for twin cooperation. The following is an example of setup for the case where twin cooperation is performed by assigning a welder to each of the two manipulators in Unit 1. 1 in the teach mode. Press F5 arc constant, and then select 2 setting of welder. The welder setting screen is displayed. Set welder 1 as mechanism 1, and welder 2 as mechanism 5. In the mechanism box, set independent for both welder 1 and welder 2 in the connection type box. 3.2 Preparations for using twin cooperation. 3 to 3. Set the welding constants. Check and set the various constants related to arc welding. Point confirm that scratch start is set to off. When scratch start is set to on, the arc always starts by means of a scratch start, so it is not possible to select the arc start method. For details, refer to 3.5.1 welding start on page 3 to 20. Set the method of retracting during restarting and the retraction distance during restarting / correction time during restarting. When the restart variation is set so that after the robot pauses during welding, it returns exactly a fixed distance, and then starts operating again. Lap start of the conventional model. The robot retracts according to this setting. When multiple welders are in the welding section, the robots retract according to the setting of the welder that has a longest retraction distance. Regarding the following items, when performing welding using twin cooperation welding in which multiple welding sections overlap each other, set the two welders to the same values. Preflow time. Arc start retry number. Wire retraction waiting time. Arc outage detect time. Wire stick check. Wire stick check start time. Wire stick recheck wait time. Wire stick release. Wire stick release / recheck number. Welding condition setting precedence time. Waiting time after welding starts. Hot start time. Arc start failure detect time. Wire retraction time. Burn back time. Wire stick check waiting time. Wire stick check stable time. Wire stick judgment time of WCR. Wire stick release time. Gas off delay time. Arc start timing adjustment time. Arc end timing adjustment time. 1 in the teach mode. Press F5 arc constant, and then select 3 constant of weld. The screen for setting the welding constants is displayed. 2 press enter in the welder box, and select the welder that is to be set. 3 press F10 scroll page to display the target item. 4 move the cursor to the target item, then enter the value, and press enter. 5 upon completion, press F12 complete. This completes correction of the welding constants. 3.2 Preparations for using twin cooperation. 3 to 4. 3.2.2 Setup concerning the input/output signals exclusive to arc welding. This section describes the input/output signals included among the input/output signals exclusive to arc welding, which are used for a twin cooperative system. For details of all of the input/output signals exclusive to arc welding, refer to Application Manual Arc Welding in the Instruction Manual. List of input signals exclusive to arc welding used in a twin cooperative system. Input signal name factory set. Input signals function. Scratch start on/off W140. This signal is used to perform scratch start. Scratch start refers to the start method by which welding is started without checking whether arc start has been completed. Abnormal. Section off W140. This signal is used so that, when an arc start failure occurs or there is no arc, welding will no longer be performed in that welding section after that. Weld off cancel W140 signal which cancels the status existing while the robot is operating in section welding off after an arc start failure or arc extinguishment occurs. Section welding off means that welding is cancelled only in the welding section concerned after trouble has occurred. WCR input twin as W140 defines the start confirmation method. Simultaneous arc start by multiple welders in a twin synchromotion system. Scratch start on/off W1 to W4 initial allocation no. 0 meaning of the signal. This signal is used to perform scratch start. This signal only functions when a robot dedicated welding power supply is being used. Operation when turned on executes arc start processing with a scratch start. Turns on the scratch start set signal page 3 to 6. Operation when turned off executes arc start processing with a normal start. Turns off the scratch start set signal page 3 to 6. Remarks. Set a value of at least 0.5 seconds as the arc outage. Detect time in the welding constant settings. To ensure that the scratch start takes place normally, Although it is possible to set the scratch start not only with a signal, but also with arc constant, setting 3 constant of weld scratch start. Set 3 constant of weld scratch start to off when using the welders as a twin cooperative system. Operator qualifications user or above 3.2 preparations for using twin cooperation. 3 to 5. Abnorm. Sect. Off W1 to W4 initial allocation no. 0 meaning of the signal. This signal is used so that, when an arc start failure occurs or there is no arc, welding will no longer be performed in that welding section after that operation when turned on. If an arc start failure or arc outage occurs, abnormality processing is performed to acquire information concerning the abnormality. An operation resumes without welding taking place in the welding section where the abnormality occurred. Turns on the abnorm. Sect. Off signal page 3-6. Operation when turned off. If an arc start failure or arc outage occurs, the abnormality is processed as an alarm. An operation pauses. Turns off the abnorm. Sect. Off signal page 3-6. Remarks. Operator qualifications user or above. Weld off cancel W1 to W4 initial allocation no. 0. Meaning of the signal. If the robot enters the welding section due to section off during arc retry, processing or arc start failure / arc outage, the section welding off status will be cancelled. Operation when turned on. If the robot enters the welding section in a section welding off status, the section welding off status will be cancelled. Operation when turned off nothing happens. Remarks. Operator qualifications user or above. WCR input twin as W1 to W4 initial allocation no. 0 meaning of the signal defines the start confirmation method during simultaneous arc starting by multiple welders in a twin synchromotion system. Operation when turned on. Confirmation of arc start of any one welder is treated as the completion of arc start, and the motion of the robot resumes. Turns on the WCR input twin as signal page 3-5. Operation when turned off. Confirmation of arc start of all of multiple welders is treated as the completion of arc start, and the motion of the robot resumes. Turns off the WCR input twin as signal page 3-5. Remarks. If the completion of arc start is defined as the time at which the arc start of any one welder can be confirmed, turn on WCR input twin as of all of the applicable welders, all of the welders in the unit. Operator qualifications user or above 3.2 preparations for using twin cooperation. 3-6. List of output signals exclusive to arc welding used in a twin cooperative system. Output signal name factory set. Output signals function. Scratch start set W140. This is output when scratch start has been selected. WCR input twin as W140. This is output when the WCR check function is enabled by the WCR input twin as input signal. Abnormal section off W140 section off was set as the operation that takes place after an arc start failure or arc outage by the abnorm. Sect. Off input signal. Section weld off W140 automatic operation was resumed by the section weld off setting after an arc start failure or arc outage. Scratch start set W1 to W4 initial allocation no. 0 meaning of the signal. This is output when scratch start has been selected. Operation when turned on when the scratch start signal page 3-4 is on. Operation when turned off when the scratch start signal is off. Remarks. Operator qualifications user or above. WCR input twin as W1 to W4 initial allocation no. 0 meaning of the signal. This is output when the WCR confirmation function is enabled by the WCR input twin as page 3-5. Operation when turned on when the WCR input twin as signal is on. Operation when turned off when the WCR input twin as signal is off. Remarks. Operator qualifications user or above. Abnorm. Sect. Off. W1 to W4 initial allocation no. 0. Meaning of the signal. Section off welding does not take place in the welding section concerned was set as the operation that takes place after an arc start failure or arc outage by the abnorm. Sect. Off input signal page 3-5. Operation when turned on when the abnorm. Sect. Off input signal is on. Operation when turned off when the abnorm. Sect. Off input signal is off. Remarks. Operator qualifications user or above 3.2 preparations for using twin cooperation. 3-7. Section welding off W1 to W4 initial allocation no. 0 meaning of the signal. The operation is underway in the section welding off status. Operation when turned on. When a welding trouble, arc outage or arc start failure occurred while section off was set as the operation that takes place after an arc start failure or an arc outage by the abnorm. Sect. Off input signal page 3-5. Operation when turned off. All the action for the welding section concerned is completed. Or when the section weld off status was cancelled by the section weld off status cancel input signal page 3-5. Remarks. Operator qualifications user or above. 3.2.3 setup for the screen edit display mode. Under the twin cooperation system. It is available to use 2 or more manipulators at the same time and individually teach a different interpolation type to each manipulator. Therefore, it is necessary to set to the mode in advance, allowing to edit the command by each manipulator on screen editing. Changing the screen edit display mode. 1. Press F5 constant setting in the teach mode. Select 2 screen constants -4. Menu selection. Next screen appears. +2 in the screen editor. Select form 2 or all. 3. Lastly, press F12 complete. Thus, the screen edit display mode has been changed. 3.2 Preparations for using twin cooperation. 3 to 8. Hint concerning the screen edit display mode. The screen edit display mode has 2 kinds of screen by each mechanism. Standard screen, displaying the data such as the interpolation type, speed, accuracy, etc. Second screen, displaying the joint angle or coordinate value of each axis. The details for the screen edit display mode are as follows. From 1 Mechanism 1, Standard Screen plus Second Screen. Mechanism 2, Second Screen. Form 2 All Mechanism. Standard Screen only all Mechanism. Standard Screen plus Second Screen. For the unit where 2 or more manipulators are set, it is necessary to set the interpolation type by each manipulator. Please select Form 2 or all. 3.4 Teaching of Twin Cooperation. 3 to 9. 3.3 Switching over the welders and mechanisms to be operated. The twin cooperative system consists of multiple mechanisms. Multiple welders are connected to the system. For this reason, it is necessary to specify the welder to be operated when welding is to be performed manually for inching or retracting the wire, for example. Also, it is necessary to specify which mechanisms are to be turned on/off when turning, weaving on/off. 3.3.1 Switching over the welder to be operated. It is necessary to select the welder to be operated when performing one of the following operations. Wire inching/retraction. Gas check. Switching over the welder to be operated manually. 1. Teach mode F key. It is possible to judge which of the welders has been selected for operation by observing the W1 indication at bottom left of F10 inching, F11 retract and F12 gas. This is an example in which welder 1 has been selected for operation. +2 while pressing enable. Press F2 select arc. The number of the welder selected for operation that is displayed at bottom left of F10 inching, F11 retract and F12 gas changes over to the number of the next welder registered in the system. 3. It is possible to inch the welder selected for operation at low speed by pressing F10 inching. To inch the welder at high speed, press F10 inching while pressing enable. It is possible to retract the welder selected for operation at low speed by pressing F11 retract. To retract the welder at high speed, press F11 retract while pressing enable. It is possible to perform a gas check of the welder selected for operation by pressing F12 gas. 3.4 Teaching of twin cooperation. 3 to 10. Switch hover between welding on/off consists of individual switch hover in which a single welder is switched on/off, and ganged switch hover in which all welders registered in the system are switched on/off together, switching each welder on/off individually. 1. Teach mode F key. Confirm that the welder number of the selected welder, W1 in this case, is displayed at bottom left of F2 weld on/off. In this status, it is possible to turn each welder on/off individually. +2 while pressing enable. Press F2 select arc. The number indicating the welder selected for operation, displayed at bottom left of F2 weld on/off switches over to the number of the next welder registered in the system. 3. It is possible to change the on/off status of the welder selected for operation by pressing F2 weld on/off. Indicates that the welder selected for operation is on. Indicates that the welder selected for operation is off. Indicates that the welding on/off status of the welder selected for operation switches over according to the status of the weld on/off input signal. In this example, the weld on/off input signal is off, and welding is off. 3.4 Teaching of twin cooperation. 3 to 11. Switching over all welders on/off together. 1. Press F6 arc condition in the teach mode, then select 1. Arc, teach/playback condition. The arc teach and playback condition setting screen is displayed. +2 Move the cursor to weld on/off. Then switch the radio buttons horizontal row of selector buttons to all using the enable plus left/right cursor keys. 3. Upon completion of the settings, press F12 complete. The settings are saved in the file, and so their statuses are retained even when the power is turned off. 4. When the display returns to the top screen of the teach mode, to all appears at bottom left of F2 weld on/off. It is possible to change the welding on/off status of all welders registered in the system by pressing F2 weld on/off. Indicates that all welders are on. Indicates that all welders are off. Indicates that the welding on/off status of all welders switches over according to the status of the weld on/off input signal. The on/off status of each welder differs according to the status of each weld on/off input signal. The on/off status displayed at F2 weld on/off indicates the status of the welder selected by F2 select arc, which is displayed when enable is pressed. Method of easily switching between to each and to all. 5 on the teach or playback mode top screen. Press the reset/or key. The shortcut R code entry screen is displayed. 6. Press the up/down key to move the cursor to R380. Change the arc welder selection, or enter 380 in the edit box directly below and press the enter key. The display switches between to each and to all of weld on/off. 3.4 Teaching of twin cooperation. 3 to 12. 3.3.2 Switching over mechanism selected for a weaving on/off operation. There are two types of switch over between weaving on/off: individual switch over of weaving on/off of one mechanism, and ganged switch over of weaving on/off of all mechanisms, manipulators or module robots, registered in the system that can perform weaving. Individual switch over of weaving on/off. 1. Teach mode F key. Confirm that the applicable mechanism number, M1 in this case, is die plate at bottom left of F3 weaving on/off. It is possible to perform individual weaving on/off in this status. +2 while pressing enable. Press F3 select robot. The number indicating the mechanism selected for operation displayed at bottom left of F3 weaving on/off switches over to the number of the next welder mechanism, manipulator or module robot, registered in the system that can perform weaving. 3. It is possible to change the weaving on/off status of the mechanism selected for operation by pressing F3 weaving on/off. Indicates that the mechanism selected for operation is in a weaving on status. Indicates that the mechanism selected for operation is in a weaving off status. Indicates that the weaving on/off status of the mechanism selected for operation is switched over according to the status of the weaving on/off input signal. In this example, the weaving on/off input signal is off, and weaving is off. 3.4 Teaching of twin cooperation. 3 to 13. Switching over all weaving on/off together. 1. Press F6 arc condition in the teach mode, then select 1. Arc, teach/playback condition. The arc teach and playback condition setting screen is displayed. +2 Move the cursor to weave on/off. Then set the radio button's horizontal row of selector buttons to all using the enable plus left/right cursor keys. 3. Upon completion of the settings, press F12 complete. The settings are saved in the file, and so their statuses are retained even when the power is turned off. 4. When the display returns to the top screen of the teach mode, to all appears at bottom left of F3 weaving on/off. It is possible to change the weaving on/off status of all mechanisms registered in the system that can perform weaving by pressing F3 weaving on/off. Indicates that all mechanisms that can perform weaving are in a weaving on status. Indicates that all mechanisms that can perform weaving are in a weaving off status. Indicates that all mechanisms that can perform weaving are switched over between weaving on and off by the weaving on/off input signal. The on/off status of each mechanism differs according to the status of each weaving on/off input signal. The on/off status indicated by F3 weaving on/off indicates the status of the mechanism selected by F3 select robot, which appears when enable is pressed. Method of easily switching between to each and to all. 5 on the teach or playback mode top screen. Press the reset/or key. The shortcut R code entry screen is displayed. 6. Press the up/down key to move the cursor to R381. Change the weaving mecha selection, or enter 381 in the edit box directly below and press the enter key. The display switches between to each and to all of weave on/off. 3.4 Teaching of twin cooperation. 3 to 14. 3.4 Teaching of twin cooperation. The twin cooperative system consists of multiple mechanisms. Multiple welders are connected to the system. For teaching the move commands, it is necessary to set the interpolation type by manipulator. For details, see the instruction manual basic operation, and it is necessary to specify the object of teaching when teaching welding commands and weaving commands. For example, in the case of a welding start command, specify which welder a command is intended for during teaching. For details of the method of teaching welding commands, refer to the application manual arc welding in the instruction manual. 3.4.1 Teaching the move command. In the twin cooperation, the interpolation action is performed by two manipulators. It is available to set up the interpolation positioning, linear interpolation, circular interpolation, by each manipulator. When the manipulator 1 is in the linear interpolation, the manipulator 2 could be in the circular interpolation, for example. However, a motion speed follows the standard mechanism. Be sure to give attention to the interpolation motion of the mechanism other than the standard one. Important. Concerning the motion speed, a motion speed of the standard mechanism is a taut speed. Meanwhile, a motion speed of the mechanism other than the standard one is calculated on the basis of the time of motion of standard mechanism by each sequence. If the amount of motion is extremely large comparing with one of the standard mechanism, the manipulator may operate at unexpected high speed. The explanation is given below with the twin cooperation unit, including all the following mechanisms. Mechanism 1, manipulator. Mechanism 4, positioner. Mechanism 5, manipulator. Teaching the move command normal. 1. Move the positioner to the teaching position. Switch the mechanism to mechanism 4. The interpolation type of positioner is fixed at joint. Move the positioner by manual operation to the teaching point. 2. Move the manipulator of mechanism 1 to the teaching position. Switch the mechanism to mechanism 1, and select a desired interpolation type. Move the manipulator by manual operation to the teaching point. 3. Move the manipulator of mechanism 5 to the teaching position. Switch the mechanism to mechanism 5, and select a desired interpolation type. Move the manipulator by manual operation to the teaching point. 4. Set up the speed, accuracy, acceleration, and smoothness, and press record. 3.4 Teaching of twin cooperation. 3 to 15. Teaching the move command. Simple teaching. 1. Press clamp/R key. The commands frequently used for F key are now displayed. Or 2. Move all the mechanisms to the teaching point, and select either F7 joint, F8, line O, or F9 circle C depending on the interpolation type. Then, the next screen appears. Item detail. Speed sets up the motion speed of main mechanism. Mechanisms other than the main mechanism operate at a speed consistent with the time of operation of main mechanism in each step. The speed can be set either by the line speed cm/min, ability %, or time sec, main, mechanism. This is the mechanism to be a standard for speed. Movement simultaneous/synchronize overlap enable/disable or numerical input mechanism. Interp. The interpolation type joint, line, circle can be set for each mechanism. The auxiliary axis such as positioner and slider is fixed at joint. Tool. The tool number can be set for each mechanism. This is available only for manipulator. 3.4 Teaching of twin cooperation. 3 to 16. 3 for detailed settings, such as the specified value of accuracy and the acceleration. Use the Details tab. To switch the tab, press close/move screen. 4 On completion of setting all the conditions, press F12 complete. Important. When teaching the move command in the twin cooperation, be sure to confirm the interpolation type in all mechanisms. Even if changing the interpolation type in mechanism 1, for example, that of the other mechanisms remains the same. Hint: the interpolation type in each mechanism can be changed on the screen edit mode for the teaching data already created or the wrong sequence. However, it is necessary to set the screen edit display mode to Form 2 or all in advance. 3.2.3 Setup for the screen edit display mode. 3.4 Teaching of twin cooperation. 3 to 17. 3.4.2 Specifying the object welder of a welding command. This section describes the method of specifying the welder to be made the object of welding commands during teaching of welding start and welding end commands. The description given here is based on the welding start command as an example. It is possible to specify a welder as the object of a welding end command, using the same method. Specifying a welder when teaching welding commands, or 1. Press F7 as, alternatively, after pressing clamp/arc, press F2 as. The screen for setting the arc welding start conditions is displayed. 2. Press enter in the welder box. A list of welders connected to the unit currently being taught is displayed. 3. Press the up/down key to select a welder, and then press the enter key. The welder box display switches over. The welder that is the object of the welding start command has now been specified. Enter the parameters of the welding start command, and press F12 complete to end teaching. 4. W2 and the object welder are displayed alongside the welding start command on the program monitor. 3.4 Teaching of twin cooperation. 3 to 18. 3.4.3 Specifying the mechanism that is the object of a weaving start command. This section describes the method of specifying the mechanism to be the object of weaving during teaching of a weaving start command. Here, the description is given based on fixed pattern weaving as an example. It is also possible to use the same method to specify a mechanism as the object of another weaving start command. Specifying a mechanism when teaching a weaving start command, or 1. Press F8 WS. Alternatively, after pressing clamp/arc, press F4 WFP. The screen for setting the fixed pattern weaving conditions is displayed. 2. Press enter in the mechanism no box. A list of mechanisms contained in the unit currently being taught that can perform weaving is displayed. 3. Press the up/down key to select a mechanism, and then press the enter key. The display in the mechanism no box switches over. R. The mechanism that is the object of the weaving start command has now been specified. Enter the parameters of the weaving start command, then press F12 complete to end teaching. 4. 5 and the object mechanism are displayed alongside the weaving start command on the program monitor. 3.4 Teaching of twin cooperation. 3 to 19. 3.4.4 Specifying the mechanism that is the object of a weaving end command. This section describes the method of specifying the mechanism to be the object of weaving during teaching of a weaving end command. Specifying a mechanism when teaching a weaving end command, plus, or 1 while pressing enable. press F8 Alternatively, after pressing clamp/arc, press F5 the functions are displayed, and the mechanism ID can now be input by FN443 weaving end. To enter the mechanism ID and press the Enter key, the mechanism that is the object of the weaving end command has now been specified, thus ending teaching of the weaving end command. 3.5 and the object mechanism are displayed alongside the weaving end command on the program monitor. 3.5 Automatic operation of the twin cooperative system. 3 to 20. 3.5 Automatic operation of the twin cooperative system. The twin cooperative system permits simultaneous welding of multiple points multi-pass welding, using multiple welders. Automatic operation of arc welding is programmed to stop the motion of the robot during normal welding, start/end in order to prevent an arc start failure or the formation of craters. However, during multi-pass welding, trouble will occur if the motion of the robot stops while an arc is generated by one welder. For this reason, a special function is provided for multi-path welding. For a general description of automatic operation, refer to basic operation in the instruction manual. 3.5.1 Welding start. It is possible to select the method of welding start processing when a welding start command is issued to multiple welders simultaneously. Scratch start. Even if an arc is not generated, the system deems that the welding start command has been executed. If all of the welders have scratch started, the robot will start even if an arc is not generated. It is possible to make a setting that prevents the robot on which arcing started normally from stopping in the event of an abnormality, such as an arc start failure, in one welder. Normal arc start. The system confirms that an arc has been generated, and deems that the welding start command has been executed. The system confirms that an arc has been generated, and the robot starts operating, used for tack welding, and similar cases. Twin arc start scratch start. Initially, the system performs normal arc start processing, and then waits until an arc is generated. It deems that a welding start command has been executed when an arc has been generated by another welder, even if an arc has not been emitted from the selected welder. For a description of welding start processing when the welding section has shifted, refer to 3.5.3 Processing by the welder and robot in the welding section. Select the welding start method. To start welding using scratch starting, turn on the scratch start signal page 3 to 4. To start welding using a twin arc start, turn on the WCR input twin as signal page 3 to 5. To start welding using a normal arc start, turn off both of the above signals. Important. To select the welding start method, set scratch start to off according to setting various constants related to arc welding in 3.2.1 setup relating to welder. When scratch start is set to on, welding always starts by scratch starting. To start welding using a twin arc start, turn on the WCR input twin as signal for all of the welders that are to be started by twin arc start. If even one welder is off, the robot will not start to operate until the system has confirmed that the arc has been generated. When both the scratch start signal and the WCR input twin as signal are turned on, the scratch start signal has priority. 3.5 Automatic operation of the twin cooperative system. 3 to 21. 3.5.2 Welding end. When multiple welders execute welding end commands simultaneously, the welding end processing stops the motion of the robot in the conventional way, and processing of craters and afterflow takes place according to the teaching conditions of the welding end command. For a description of welding end processing when the welding section has shifted, see 3.5.3 Processing by the welder and robot in the welding section. 3.5.3 Processing by the welder and robot in the welding section. For multi-path welding, it is possible to teach welding command to each welder, so it is also possible to shift the welding section. There are several points that differ from the standard specifications in order to ensure that welding work is not impeded when the welding section has shifted. 100% joint AAT1 welder 1 welder 2. 1 as W1, off, 00, 150A, 18.0 volt, 60 centimeters slash M, welding start, 200 centimeters slash M lin AAT1, 2 as W2, off, 00, 150A, 18.0 volt, 60 centimeters slash M welding start, 200 centimeters slash M lin AAT1, 3AW2, off, M, 150A, 18.0 volt, 0.5 second, 0.5 second, welding end, 200 centimeters slash M lin AAT1, 4AW1, off, M, 150A, 18.0 volt, 0.5 second, 0.5 second, welding end, 100% joint AAT1, 1, welding start when all of the welders are in non-welding sections, as command processing when scratch start was enabled, preflow robot motion stop, arc start processing robot motion start, 2. Welding start when another welder is in the welding section, as command processing when scratch start was enabled. Preflow arc start processing the motion of the robot does not stop. 3. Welding end when another welder is in the welding section. A. Command processing. Anti-stick processing welding check processing post-flow. The motion of the robot does not stop. 4. Welding end when another welder is already in a non-welding section. A. Command processing. Robot motion stop crater processing anti-stick processing welding check processing post-flow robot motion start 3.5 automatic operation of the twin cooperative system 3 to 22 3.5.4 speed of motion in the welding section. A movement command in the welding section causes the robot to move, not at the speed taught by the movement command, but at the welding speed taught by the welding start command. The robot moves at the welding speed determined by the welding start command that was taught immediately prior to the movement command. Non-welding section speed of motion under the move command. 100% joint AAT1 moves at the taught speed. 1 as W1, off, 00, 120 A, 18.0 volt, 50 cm M. Welder 1 welding start. 200 cm M lin AAT1 moves at the welding speed of 1, 2 as W1, off, 00, 150 A, 18.0 volt, 60 cm M. Welder 1 change of condition. 200 cm M lin AAT1 moves at the welding speed of 2, 3 as W2, off, 00, 140 A, 18.0 volt, 70 cm M welder 2 welding start. 200 cm M lin AAT1 moves at the welding speed of 3, 4 as W1, off, 00, 150 A, 18.0 volt, 70 cm M welder 1 change of condition, 5 as W2, off, 00, 150 A, 18.0 volt, 60 cm M, welder 2 change of condition, 200 cm M lin AAT1 moves at the welding speed of 5, AW2, off, M, 150 A, 18.0 volt, 0.5 second, 0.5 second. Welder 2 welding end 200 cm M lin AAT1 moves at the welding speed of 5, AW1, off, M, 150 A, 18.0 volt, 0.5 second, 0.5 second. Welder 1 welding end, 100% joint AAT1 moves at the taught speed. Point the movement command in the welding section causes the robot to move at the welding speed determined by the welding start command taught immediately prior to the movement command, regardless of the mechanism that is connected to the welder. In the above example, welder 1 is still in the welding section when welding of the welding section in which welder 2 is located has ended. The movement command at this time causes the robot to move, not at the welding speed determined by the welding start command of welder 1, but at the welding speed determined by the welding start command of welder 2. This is because the welding start command taught immediately prior to the movement command is the welding start command 5 of welder 2. 3.5 automatic operation of the twin cooperative system. 3 to 23. 3.5.5 multi-weaving. The following precautions must be observed when weaving simultaneously using multiple mechanisms. When move at stop time is set to not exist by the weaving command. To set move at stop time to not exist, it is necessary to set the parameters so that multiple weaving mechanisms stop simultaneously and also remain stopped for an equal length of time. Concretely, perform teaching as indicated below. Make the value of frequency the same for all mechanisms. Make the parts 1/4, center, 3/4 for setting stopping time the same for all mechanisms. Make stopping time the same for all mechanisms. Make the setting for keep weaving time the same for all mechanisms. If these conditions are mismatched, preventing weaving from being performed, an abnormality E4102 it is weaving condition disagreement will occur. 3.5.6 Pause and restart. If the restart variation is set so that after welding is paused, the robot returns exactly a fixed distance, and then restarts welding lap start of the conventional DIN model. When the robot restarts after pausing during operation, it first returns exactly the specified distance with respect to the weld line, and then restarts welding. In this case, the distance through which the robot returns is set by the welding constant setting for each welder. It is the longest distance among the settings of the welders in the welding section. Point the welding constant setting that causes the welder that was paused during welding to return exactly a fixed distance, and then resume operation is the method of reversing when restarting and also the reversing distance during restarting/correction time during restarting. 3.5 Automatic operation of the twin cooperative system. 3 to 24. 3.5.7 Welding on/off during automatic operation. The welder differs from the standard specifications in respect of several points. This is to prevent trouble during welding work if welding is turned on/off while the welder is in the multi-pass welding section. 1. Motion that takes place when welding is turned off on while no other welder is performing welding work. Preflow robot motion stop scratch start processing. When scratch start is enabled, robot motion start. 2. Motion that takes place when welding is turned off on while another welder is performing welding work. preflow/gas preflow scratch start processing. When scratch start is enabled, the motion of the robot does not stop. 3. Motion that takes place when welding is turned on off while no other welder is performing welding work. Robot motion stop. Anti-stick processing post-flow robot motion start. 4. Motion that takes place when welding is turned on off while another welder performing welding work. Anti-stick processing post-flow. The motion of the robot does not stop. 3.5.8 Weld failure. You can specify one of two operations to take place when a welding abnormality is detected. 1. Automatic operation stops immediately. Or 2. The welder in which the abnormality was detected stops welding and simply goes into a section, welding off status. But automatic operation continues. Welding abnormalities concerning which the operation after detection can be specified are as follows. If any abnormality than these is detected, the system will stop immediately. Arc start failure. Arc outage. Specifying the operation to take place after a welding abnormality was detected. To resume operation when arc start failure/arc outage occurs, turn on the abnorm sect. Off input signal page 3-5. Welding stops in the welding section in which a welding abnormality occurred, and automatic welding continues in A section, welding off status. However, automatic welding will pause in the following cases. If no other welder is performing welding work when a welding abnormality was detected. When a welder completed welding work while automatic operation was taking place in A welding off status due to the detection of a welding abnormality in another welder. When a welder that had been performing welding work in a welding section in which automatic operation was taking place in A welding off status due to the detection of a welding abnormality in another welder went off upon completion of welding in that section. When a welding abnormality occurred in a welder that had been performing welding work while automatic operation was taking place in A welding off status due to the detection of a welding abnormality in another welder. When operation resumes after a pause, the welder in which the abnormality was detected operates in A welding off status until completion of the welding in the section concerned. This function puts the system into A welding off status while allowing it to continue operation in the case where a welding abnormality was detected in one of multiple welders performing welding work in the same unit. If a welding abnormality was detected, and there was no other welder unit performing welding work in the same unit, the system will pause regardless of whether or not welding work is taking place in another unit. 3.5 Automatic operation of the twin cooperative system. 3-25. Canceling the section welding off status after a welding abnormality was detected. To cancel the section welding off status after a welding abnormality was detected, turn on the section welding off cancel input signal page 3-5. The welder that continued to perform automatic operation in A welding off status will go on and start welding work.